Hello my friends, welcome to Prismatis online class. In this class, we are going to look at the concept of what? Modulus of complex number and the argument or amplitude of the complex number. So that is what we are going to look at now. Okay, the modulus of complex number z equals to x plus iy is its distance from the origin when represented on the Agag diagram. The length of the arm OP is the modulus of the complex number z. We denote the modulus as the magnitude of z is equal to the magnitude of x plus I y is equal to square root of x square plus y square. That is the definition of modulus of complex number, and the formula of the modulus of complex number is equals to x square plus y square. That is square root of x square plus y square. Okay, now let's look at argument of complex number. So argument, or you call it amplitude of complex number. The argument of complex number is the angle between the position real OP of the complex number on the Agag diagram and the positive real axis. We denote the argument of complex number as z equals to theta equal to tan inverse of y over x. That is all about amplitude of the complex number. Okay, now we are going to look at this diagram here. So this diagram, when you look at this diagram, from here, from this point P to point 0 to P is known as that is the distance between from 0 to P is known as the modulus. But the angle they made between this place and this place, which is here, is called the amplitude, or you call it argument. So that is how to do this. But now we are going to drive them from this place. Let's drive out the formulas. How to generate the formula for modulus, the formula for argument, and the formula for what we call polar form of complex number, or you call it trigonometric form of complex number. Now let's start. 1. Remember Pythagoras theorem. Pythagoras theorem that stated that the r square is equal to x square plus y square. Pythagoras theory stated that the square of the longest side is equal to the sum of the square of the two opposite sides, called adjacent and opposite. So that is the square of the longest side, which is hypotenuse, is equal to the sum of the square of the two opposite sides, called adjacent and opposite. So that is the reason why we have this is the longest side. The square of it is equal to the sum of the squares of the two opposite sides, which is x square y square. Now how do we do this? We want to make s the subject of the formula. We square root the both sides. Now this is equal to square root of x square plus y square. This will cancel this. Now r is equal to square root of x square plus y square. So this formula is called the modulus of complex number. Is called the modulus of complex number. So this is the formula to solve the modulus of complex number. Okay, now on the same diagram we are going to form another we are going to generate another formula from the same diagram. Now let's start. before we do that, we need to recall what we called then SOHCAHTOA. We need to recall what we called what? SOHCAHTOA. Always remember that this side is what? Y-axis, while this side is x-axis. In other words, this side is what? Real part, where this side is what? Imaginary part. Okay, record this SOHCAHTOA. Now, where so implies sine theta equals to opposite over hypotenuse, and ka implies what? Cos theta equal to what? Adjacent over hypotenuse. And TOA implies tan theta equal to opposite over what? Adjacent. Okay, from this place now, from this diagram, we want to generate what we call sine theta from this diagram. So it's going to we are going to have it as sine theta. Sine theta is equal to, what is the opposite? Look at this. Wherever this angle fits is opposite, and wherever this fits is the what? Hypotenuse. So the opposite here is what? Y over hypotenuse. What is our hypotenuse? Our hypotenuse is what? Over R. This is over R. So from this place, make Y the subject of the formula. From this place, make Y the subject of the formula. We have this as over 1. So we do what we call cross multiply. Y equal to what? R sine theta. Call it equation 1. Very important. Call it equation 1. Okay. Now, let's continue. Let's continue here. Equation 1. Okay. Now, let's look at cos theta. Cos theta is equal to what? Adjacent over what? Hypotenuse. Our adjacent here is what? X. Hypotenuse is what? R. This is over what? R. Do cross multiply. Cross multiply. We have this as X is equals what? R times cos theta, which will give us R cos theta. Call it equation 2. Very important. Now, we have another one called tan theta. Tan theta equals what? Tan means what? Opposite over what? Adjacent. Our opposite is Y, and our adjacent is what? X. So now, what do we make subject of the formula now? We have already gotten Y and X. So we have to make tan. We have to make tan theta the subject of the formula, which means tan theta is equal to tan inverse of what? Y over X. Call it equation 3. Okay. This equation 3 is called the amplitude, or what? Argument of complex number. So the formula for argument, whenever you want to find the argument of complex number, is equal to tan theta. Tan theta is equal to tan inverse of Y over X. That is how to get it. Thank you. Now, I want to generate the formula called what? Polar form of complex number. How do we do that? Okay. Okay, always remember that Z, which is complex number, is equal to X plus IY. And I want to generate polar form of complex number, or we call it trigonometric form of complex number. How do we do it? From equation 3, equation 2, we have that X is equal to R cos theta, where X is equal to R cos theta. and the y equals to r sine theta. So we replace it in above equation. Z is equals to what? Wherever you see s, call it r cos theta, which is r cos theta plus I into what? R sine theta. So looking at this, we have r here, we have r here, factor r out. We have that z is equals to r into cos theta plus I sine theta. So this is what we call what? The polar form of complex number. So, and it is always denoted by r into theta is equal to r into cos theta plus I sine theta. So this is what called, this is called what? Polar form or trigonometric form. Trigonometric form of complex number. So finally, we have generated three formulas. First formula is what we call modulus of what? Complex number. That is what? That z is equal to square root of what? X square plus what? Y square. This is like this, or we call it r. You can easily call it r. And we have that theta is equal to what? Tan inverse of what? Y over what? X. And we have that our polar form of complex number is equal to r, which is the magnitude, which is what? The modulus, into what? Cos theta plus what? I sine theta. So whenever they ask you to find the polar form or trigonometric form of complex number, you apply this formula. Very, very important. You apply this what? Formula. Very, very, very important to find trigonometric or polar form of complex number. So that is how to drive it. And I know you understand it. Thanks and God bless you. Now I'm going to solve one example. Let's just find one example and solve and see how the thing look like. Okay. Now let's just say, let's determine what? That z okay, determine modulus argument and polar form of z equals to 1 plus I. Let's look at this from this question on the board. Determine what? The modulus, argument, and what? Polar form, or some textbook will say trigonometric form. Either you call it polar form or you call it what? Trigonometric form. Okay. Solution. How do we solve this? Before you solve any equation from this, you need to what? First of all, translate that equation, that complex number, to what we call what? Agard diagram. Let's do it. Now I have this as 1, 2, minus 1, minus 2. Let's just say I, 2i, 3i. This is y-axis. Let's just say minus I minus 2i minus 3i. Now, this is when x is 1, y is also 1. When x is 1, y is also what? 1. That means when x is 1, trace it. So you can now draw the straight line. So now it means that z equals what? 1 plus I. So that is 10. So here now, so with this place, we always tell you whether this is in first quadrant, second quadrant, third quadrant, and fourth quadrant. So, and remember that in first quadrant, both sine, cos, and theta all are what? Positive. So, okay. Now, let's go. First of all, we are going to determine the modulus. And the modulus z, which is the same thing as r, is the same thing as what? Square root of what? X square plus what? Y square. Where our x is equal to 1 and y is also 1. So our r modulus is equal to what? Square root of what? 1 plus what? 1, which is our r is equal to what? Sod 2. So that is what? The modulus of this. Okay, now let's look at the arguments. The argz, that is the second one, argument. The argz is equal to what? You can call it theta, is equal to tan inverse of what? Y over what? X. Tan inverse of y over x. Our y is what? 1 and x is 1. So we have this as tan is equal to tan inverse of what? 1 over what? 1. And which will give us what? That theta is equal to tan inverse of what? 1. And tan inverse of 1 is equal to what? 45 degrees. Always remember that this is 45 degrees. You may they may ask you to leave your answer in a radii or leave your answer in a degree. But if you want to convert, always remember that 1 degree is equal to what? Is equal to what? Pi over 180. Now I want to convert this. 45 degrees will give me now what? Will give me what? 45 degrees. 45 degrees multiplied by what? 180. Oh, multiplied by what? Pi over 180. So which will still give me that this will give me what? 45 pi over what? 180. This cancel itself, cancel this. Finally, we are going to have it as what? Pi over what? 4. So either you leave your answer in degree or you leave your answer in what? In what radii. So 45 degrees is equivalent to what? Pi over 4. So that is how to solve it. So that is for your this thing, for your argument. Now we are going to go for a solve polar form of complex number. Polar form. How do we solve the polar form? How do we solve the polar form? Recall that r theta is equal to r into cos theta plus I sine theta. You have already getting what? Your r and theta. So now what do we have to do now? Let's just, our r is what? Sod 2. Sod 2 into what? Our theta is what? 45 degrees. 45 degrees, or you can say pi over what? 4. This is equal to now sod 2 into cos 45 degrees plus I sine what? 45 degrees. Or you can have it as like this, that sod 2 into what? Pi over 4 is equal to what? Sod 2 into cos what? pi over 4 plus I sine pi over 4. Close it, and that is your answer. Okay, I hope you understand it. We gave a definition of what complex modulus of complex number. Also gave a definition of amplitude, or what we called argument. And we show how to derive the modulus of complex number formula, amplitude formulas, and the polar form of complex numbers. We have derived it. We even show the example on the board, how to solve them. Thanks, and God bless you. Remember to subscribe to my YouTube channel, Prismatis Online Class. Bye.